In this video, we're going to demonstrate how to properly prepare graphs to determine the melting point of a single solid of stearic acid and a mixture of stearic acid with another solid. You can see that I've already inputted the data from our experiment, where we've put time as the first column, average stearic temperature as the second column, and then the third column that you need is this mixture column, so the temperatures of the mixture. I've also included two columns that you should have recorded, but you do not need to input into Excel. So this is the change in the average stearic acid temperature going from the first point to the second point. And in this case, that first change is 0.54. The reason you don't need to put this in Excel is you won't use it you won't actually be graphing this data, though we will be referring to it in order to decide how to correctly graph the data. So you can see that I've highlighted the change data in two different colors. The first color is blue, and all of these values for change are 0.5 or greater. And all of the change values below that are highlighted in orange are below 0.5. And so even though we collected all of this average stearic data as part of one experiment, we're going to graph it as two separate pieces, split into this first half where the change is greater than 0.5 and the second half where the change is less than 0.5. What we'll then do is we'll repeat everything that we do with the average stearic data for our mixture data, and we'll use the change values for that data set to determine where that cutoff point should be right here. Now we're ready to insert our graph. So we'll do that at the top. We have the Insert button, and then there are several different chart types we can choose from. Now the layout of your particular Excel may be different depending on the version, but you should have most of the same options that you're going to see here. In this case, we would like to select a scatter plot, and we want to select one with dots that are not connected by lines. This is going to give us a blank chart, and we're going to add our data. So in order to do this, I'm right-clicking on the chart, and then I will select Data. Now we have the opportunity to add our data series. And for this graph, we're only going to use the average stearic data on the left, but we're going to graph two separate data series, one with the blue data, one with the orange data. Because the change values are all greater than 0.5, we're going to use that as our series name. The X values that we want are the times, again, just for these blue data points. So we'll select those values right here. And then the Y values that we want are the average stearic values. You can see it has this extra little piece at the beginning, which is throwing off the graphing, so let's just delete that and re-highlight. There we go. Now if we hit OK, we've added our first data series. We now want to add a second data series, still using the average stearic data, but now for the orange points at the bottom. So we'll title it less than 0.5 temperature difference. We'll select the times as the X values, and we will select the average stearic values for the Y values. And now we can press OK and see what our graph looks like. You can see that the temperature of the stearic acid slowly decreased over time, and it decreased more and more slowly as time progressed. We want to, before we go any further, let's do a little bit of labeling of this graph so we know what we're looking at. The easiest way to do this is to choose a different layout for our graph. So if we click here, the first option actually gives us everything that we need. It gives us a chart title, axis titles, and we already have a legend, and that's going to remain. So all of the data on this graph is from our average stearic measurements. So that's what we'll call this graph. Our x-axis has our time in seconds, and then our y-axis has our temperature in degrees Celsius. Our next steps are to add trend lines to both of these data sets separately Because the point of intersection of the two data sets is going to give us the melting point of the stearic acid. So in order to do this, I'm going to right-click on one of the blue data points first and add a trend line. So it's automatically going to select a linear trend line, which is correct. That's exactly what we would like. But if we scroll down, we want to make sure that we display an equation on the chart so that we can see what the values are. I'm also just going to make a small format change so that you'll be able to see it more clearly. So now we can see on the graph that we have a blue trend line overlapping our blue data, and here's the equation of that trend line. We're going to do exactly the same thing for the orange data. Add a trend line, display the equation on the chart, and I'll make it clearer to see on the graph. At this point, we now have done everything that we need to with this graph. And all we need to do to find the melting point of the stearic acid is to find the intersection between this line and this line. Before we do that, I want to point out that we can estimate that quite well just by looking at this graph. So we can see that these two lines should intersect right around this point. And so the melting point will be the temperature at that point of intersection. So when we calculate the melting point, we expect to get a value based on this data very close to 70 degrees Celsius. So when we get our actual value, we're going to want to check it and make sure that it's close to what we see on the graph. And if it's not, it means something went wrong with our calculations. The final step to finding the melting point for the stearic acid is to use Wolfram alpha. You can see that I've gone to the web address right here. Use Wolfram alpha to calculate the intersection between the two lines that we have in Excel, and the Y value will give us the melting point. So what you're going to do is type into the box on Wolfram alpha first one of the curves, then a comma, and then the second curve. So you can see we have two Y equals equations representing those two graphs. And then we'll hit the equal sign. And Wolfram alpha is going to now calculate the X and Y coordinates of that intersection point. You can see that they've graphed these two lines here, and it looks very different from our graph because ours was focused in just on that little area right there. But what it also does is at the bottom, it's giving us the X and Y values of that intersection point. And as we mentioned, the Y value is the temperature at the intersection point. And this value in our case is 69.5 degrees Celsius. And that is in fact very close to the value of 70 that we estimated from the graph, so we can be confident that we've typed our equations in correctly and that we've used the correct value. You'll note that it could be easy to accidentally use the X value here, and then you would get a very unrealistic melting point for the stearic acid. Now that we've done all of the graphing and calculations for our stearic acid sample, you'll now go back and follow the exact same steps using your mixture data, creating a separate graph and doing a second intersection calculation to get a new melting point.